interpreters, and compilers. So in this lecture, we are going to look at an introduction. We are going to look at the compilers, interpreters, compare them together. So the compiler and the interpreter perform similar tasks. They are both used to convert source code, which is a high-level language written, into a machine code, which is understandable by computers. In general, computer programs are written in a high-level language that the humans can easily understand. The programmers can easily understand in order to write it. However, the computers will never understand the high-level language. So we need to convert it to a machine language to make it readable for computers. Compilers and interpreters are used in different environments to do this job of transforming from high-level language into machine code. The compiler is a translator that takes high-level language as input and produces low-level language, or the machine or assembly language, as output. The job of the compiler is to transform code written in a programming language like Java or C++ or Python into a machine code, which is a format of zeros and ones that a computer can understand and can be able to execute the instructions as stated by the machine code. The compiler is more sophisticated than assembler because it checks for various limits, ranges, and errors. However, the runtime is longer and it occupies more memory than the assembler. It's because a compiler processes the entire program before translating into machine code. So it has to check all the program before transforming it into machine code. What's the role of a compiler? The compiler then is doing the translation from high level into an intermediate assembly level, and then the assembler will take this intermediate assembly level, will transform it into machine code. So it's assembled by the assembler into machine code. So from the high level, the compiler will transform it into an assembly language, which is then assembled into a machine code. So the process of compilation is as follows. The first phase, the programmer creates the program in the editor and store it on the disk. So the editor phase, it's written by the language understandable by the programmer. The phase 2, it's called the preprocessor phase, where the preprocessor program processes the code. It's called the preprocessor phase. The third one is the compiling phase that creates object code stored into the disk. The fourth one, it's the linker phase, which will link the object code with the libraries creates in order to create an executable files and store it on the disk for later execution. What are the good points of a compiler? A compiler code runs faster in comparing to interpreted code. The compiler helps in improving the security of the application, and compilers are offering debugging tools that help fixing errors easily. However, compilers comes also with some negative points. The compiler cannot catch all the errors. It can catch only syntax errors and some of the semantic errors, and the compilation can take more time in the case of a bulky code. What about the interpreter? The interpreter is a program that translates a programming language into a comprehensible language by the machine. The interpreter converts high-level language into intermediate language that may include pre-compiled code and source code. As I was mentioning before, it's similar to a compiler. Difference is the interpreter is doing this line by line, not as a whole as the compiler. So it translates only one statement of the program at a time. Interpreters are often smaller than compilers in terms of file size. What's the role of an interpreter? The primary role is to translate code into a target language. It works line by line on code, converting high level to direct machine language. So a high level by the interpreter into direct machine language, which is then will be interpreted or executed on a virtual machine. The positive points of an interpreter: programs written in interpreted language are easy to debug. They allows the management of memory automatically, and it reduces the risk of memory errors. It interprets as well the language in more flexible than a compiled language. However, the negative points of an interpreter: it can run only the corresponding interpreted program. So an interpreter will be used on one program. An interpreted code runs slower in comparison to compiled code. Now, to compare interpreter and compiler, a compiler will compile like C++ or C or Go or Fortran or Pascal. The language is by compiling transformed into machine code, which is ready to run. At the interpreted level, like Python or JavaScript or PHP or Ruby, it's written by a language that's interpreted, which will make it ready to run on a virtual machine, which will then be a machine code. So a compiler, the steps of programming of a compiler, it starts by creating the program or editing, analyzing the code by the compiler by throwing errors in case of any incorrect statement so that the programmer can correct it. If there are no errors, the compiler converts the source code to machine code. Then comes the linking of the various code into one runnable program, which will finally be run. However, the interpreter, the program is created, then linked files or generating machines code is not required an interpreter, so execution of source code statement one by one after the program is created. The compiler saves the machine language in form of machine code on disk. However, the interpreter does not save the machine language. The compiler codes run faster than interpreter. Of course, interpreter runs slower than the compiler. Any change in the source program after the compilation requires recompiling the entire code. However, in interpretation, any change in the source program during the translation does not require retranslating the entire code. In the compiler side, it does not require source code for later execution. In the interpretation side, source code is needed every time the code should be interpreted. In the compiler side, execution of the program takes place only after the whole program is compiled. However, in the interpretation side, the program is executed line by line, so at every line is checked and then evaluated. In the compiler side, the use of compiler mostly happens in production environment. In the interpretation side, the use of interpreter is mostly programming and development environment. In the compiler side, object code is permanently saved for future use. In the interpreter side, no object code is saved for future use. Some use cases, the compiler is used for language like C, C++, and Java. It will produce standalone executable or a bytecode for virtual machine. On the interpreter side, Python and JavaScript and Ruby are used languages used for scripting, rapid prototyping, and web development. As a summary for this lecture, the compiler translates source code into machine code or intermediate code before execution. However, the interpreter executes the source code line by line directly by translating executing instructions.